Hi everyone, Mrs. Pullen here. In this video, we're going to talk about how to find the length of a line segment in the coordinate plane. So essentially what we're going to do in this video is we're going to highlight three different methods that we can use. The first method that we're going to discuss, I'm going to call the counting method. So the counting method is going to look something like this. If I have 2 points that lie on the coordinate plane, so I'm going to sketch an X, I'm sorry, that's a Y, and an X axis or axes. Okay, and let's say I have 2 points, and let's say they look something like this. So this is a vertical line. So let's say that this is A and this is B. So if you have a vertical line, the counting method is simply starting from point A and counting the number of spaces that it takes or the distance from A to B. So starting at, this looks like what? It's 4, if this was each box was 1. So counting down to B, 1, 2, 3, 4, 5, 6, your distance here looks like it would be 6. There's 1, 2, 3, 4, 5, 6 equal sections. We can do or apply the counting method to horizontal lines. So let's say I have a different line segment that looks something like this. So we'll call this C and D. So if I have a horizontal line, I can simply count 1, 2, 3, 4, 5. So this line segment would have a length of 5. So when we're using the coordinate plane or we're talking about the coordinate plane, I want you to think about it as a ruler. So when we go through and we find the distance, essentially we're measuring the length, and we can say that CD, the measure of CD, is equal to 5. And over here we can say that the measure of AB is equal to 6. Now, the counting method is only going to work if you have a horizontal or a vertical line. So in the event that you don't, I'm going to introduce the second method right now, and we're going to use right triangles. So we haven't this year talked about right triangles yet, or any kind of triangle, but you have learned about it before in the past. So I just want to highlight a little bit of review. If we were to take a look at a right triangle consists of one right angle. You have 2 legs, so I'm going to call this A and B. And then remember, the hypotenuse, the largest side, is always going to be C. So the relationship of a right triangle, we can use what's called the Pythagorean theorem. So the Pythagorean theorem says the relationship between the 2 legs. So if this is a leg and this is a leg, we can say a squared plus b squared equals c squared. That's the relationship between all 3 sides and the tool that we're going to use when we talk about the right triangle method. So if any of this does not sound familiar, I would recommend looking up the Pythagorean theorem. I will also be more than happy to go over any of this in class. So let's take a look at what it looks like on the coordinate plane. So I'm going to sketch a y-axis and an x-axis, and I am going to, let's start with the point 1, 5, 1, 2, 3, 4, 5. I'm going to call this A, and then 4, 1, 1, 2, 3, 4, 1. I'm going to call this B, and if you look at this line segment here, this is it's not a horizontal line, it is not a vertical line. So what we can do here is from A, I can sketch vertically until it lines up where I can go horizontally over to B. And those 2 distances, so using the counting method, 1, 2, 3, 4, this is 4 over here. 1, 2, 3. This is 3 over here. Now I have a right triangle and using that Pythagorean theorem. So this is your a squared, your b squared, and the Pythagorean theorem says a squared plus b squared equals c squared. So essentially when you're using the triangle method in the coordinate plane, the length of what you were trying to find, that's always going to be your c. So that's what you're going to be trying to find here. The horizontal and vertical lengths are what you're going to use for your a squared and your b squared. So 4 squared plus 3 squared equals c squared. 4 squared is 16, right? 4 times 4. 3 squared is 9. 3 times 3 equals c squared. 16 plus 9 is 25. C squared, and then you take the square root. So the square root of 25, that is a perfect square, and that is going to give you a length of 5. So the length of AB is going to be 5. Taking a look at another example, I'm going to use the same coordinate plane, and let's say I have the points -3, -4. 1, 2, 3, 3, 4. I'm going to call this one C. And then I have 1, -2. So 1, -2. I'm going to call this D. So now let's take a look at this line segment. Again, it is not a horizontal and vertical line. So what I want to do is to break it up. So I'm looking at horizontal and vertical lines. So I can use something that looks like this. So horizontally, 1, 2, 3, 4. This has a length of 4. Vertically, it has a length of 2. Now remember, the original length that you were trying to find, that is your c. So a squared plus b squared equals c squared. We have 2 squared plus 4 squared equals c squared. You could also say the reverse, 4 squared plus 2 squared, doesn't matter. So 4 plus 16 equals c squared. And then 4 plus 16 is going to be 20. Square root, square root. So c is going to equal the square root of 20. Now, I'm going to quickly go through this, but if you need some review on simplifying radicals, please refer to the simplifying radical video. Now, taking a look at this square root, remember you're looking to break it up to two numbers that multiply to 20, one being a perfect square. So if I do that, I can rewrite this as 4 times 5, right? 4 times 5 is 20, and then separating it, the square root of 4 and the square root of 5, 4 is the perfect square. So the square root of 4 is 2, and then square root of 5 is not a perfect square, so we leave it. And often you're going to see the wording of it as keep it in simplest radical form. Let me write the words down so you're familiar with it. Simplest radical form. That's what you're looking to do. You want to break it down as much as possible. And like I said, if you need review, please visit that video. Now, the last thing I'm going to conclude, and then I will show you at a later point in time the actual derivation. It will be provided to you in some of the notes, and it would definitely be a helpful thing to look at. But using the Pythagorean theorem and the coordinate plane, if I mash them together, the third method is going to be something called the distance formula. Okay, so I encourage you, hold on, I gotta spell it, formula. I encourage you to take a look at the relationship between and where it comes from. But for now, let's take a look at what the distance formula says. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, and then this is the formula that you can use to find length for any segment. Okay, it doesn't have to be horizontal, it doesn't have to be vertical, it doesn't have to be neither horizontal or vertical. This will work for everything. Now, the beautiful thing about this is that if you memorize this formula, then this is a tool that you can put in your tool belt to find length. So let's take a look at one more example. And I'm just going to give you the coordinates. Let's say we have -3, 4, and let's say we have 2, -3. So whenever you're dealing with ordered pairs, what I recommend doing is labeling x1, y1, x2, y2, because when you're plugging it into the formula, it is super, super easy to make a mistake. So x2, I'm actually even going to underline as I plug it in, minus x1, minus a -3. And you also have to be careful with that sign. Plus y2 is -3 minus 4 squared. So we simplify under that radical. Whenever you subtract a negative, you're left with a positive. So 2 plus 3 is 5. Plus -3 minus 4 is going to give us -7 squared. Now, 5 squared is 25, still under the radical. -7 squared, remember that's the same thing as saying -7 times -7. So that's going to give you a positive 49. You should never have, being that you're squaring both instances, you should never have a negative when you get to this step here. 25 plus that 49 is going to give us the square root of 74. Okay, and then you always double check if you can simplify it. But for now, what I'm going to do is leave it as that. Okay, so if you have any questions, please write them down and we will go over everything and anything in class.